Good morning to all. Now we are discussing Unit 6 solid state. What are the classification of crystalline solid? The crystalline solid classification. First one is about the ionic solid. Next, covalent solid, molecular solid. These are, and also one more, metallic solid. These are the four types of solid. Before that, we have to discuss isotropy and about anisotropy. What is about the isotropic means? Uniformity in all direction. Isotropic means they have identical values of physical properties such as refractive index, thermal conductivity, electrical conductance, etc. in all direction. Anisotropy, the property which depend on the direction of measurement. Here the crystalline solids are anisotropy because what is the reason means they show different values of physical properties and also it can be measured along different direction. Please look the book in the page number 178. They have one diagram about the anisotropy in crystal and about the isotropic in amorphous solid. First one, the crystals are arranged. First one is a green colored big circle. Next about the rose colored red colored small circle like that. They are arranged in a regular pattern. They are arranged in a systematical way. Regular patterns. So it can be measured in along different direction. And also they show the different values of physical properties. When the isotropic in amorphous solid, here the arrangement is randomly. That is irregularly they are arranged. That is about the isotropy. Classification of crystalline solid. First classification is about that ionic solid. What is about the ionic solids means all of you know that one. It is one of the charged particles. That is about we are saying cation and anion. For example, sodium chloride, Na plus and Cl minus ion. The structural unit of ionic crystals are cation and anions. The structural unit of ionic crystal are cation and anion. Here the ionic crystals are bounded, otherwise bound together by a strong electrostatic attractive force. Here one of the cation is surrounded by many anions and also one of the anion is surrounded by many cations. One of the cation is surrounded by many anions and also one of the anion is surrounded by many cations to increase the attractive force. Ionic crystals possess a definite crystalline structure. Many solids are cubic close packed. We can draw the structure of one of an ionic crystal. How can we draw the structure of ionic crystals means? You can join here like that. This is the structure of ionic solid. Next, we can discuss about what are the characteristics of ionic solid. This is one of the important 3-mark question. What are the characteristics of ionic solid? The ionic solids are hard and brittle. Hard and brittle. The ionic crystals have high melting point. High melting point. The ionic solid do not conduct electricity. Because in solid state, ionic crystals does not conduct electricity. It acts as an insulator. Here, in the solid state, there is no movement of ions. In solid state, there is no movement of ions. Here, the ions are fixed in their lattice site. Fixed, there is no movement. But the ionic crystals are dissolved in water. Here the ions can free to move in the solution. So, in the liquid state, ionic crystals are good conductors. They are hard and only strong external force can change the relative position of ions. These are some points, one of the 3-mark question. Next, about covalent solid. In covalent solid, the constituent atoms are bound together in 3-dimensional network. So they are very hard. They have high melting point. They are poor thermal and electrical conductors. Some of the examples are insulator. So in some of the examples, because it is an insulator, SiO2, diamond, quartz. Next, we can think about molecular solid. Here, molecular solid means their constituent ions are molecule. Here, constituent ions are molecule. So, in the molecular solid, the constituent are neutral molecules. Here they have one force. What is that force means? Van der Waals. Weak van der Waals force. The molecular solids are soft and they do not conduct electricity. They are classified into 3 types. One is about that non-polar molecular solid, polar molecular solid, and a hydrogen bonded molecular solid. In non-polar molecular solid, the constituent molecule are held together by weak dispersion force. Otherwise, we can say London force. They have low melting point. Examples: naphthalene and resin. These are some examples. Next one, polar molecular solid. The constituent are molecule. Here the constituents are molecule. They are formed by polar covalent bond. They are held together by strong dipole interaction. They have high melting point. Here the examples are solid CO2, solid ammonia, etc. Next one, hydrogen bonded molecular solid. Hydrogen bonded molecular solid. Here the constituents are held together by hydrogen bond. They are generally soft solid under room temperature. This is also an insulator. It cannot conduct electricity. The examples of solid ice, glucose, urea, etc. Next, one of an important question, metallic solid. In metallic solid, the lactic points are occupied by positive metal ion. Positive metal ion. In the remaining space, the remaining of the space, they have a cloud of electron. Cloud of electron. Otherwise, we can be say a sea of mobile electrons present in the entire crystal. Mobile electrons means moving electrons. All of you know that one. Metallic solids are conduct electricity. Metallic solids are hard. They have high melting point. The metallic solid possess electrical and thermal conductivity. Metallic solids possess bright luster. For example, copper, silver, gold, iron, zinc, etc. Next, we can discuss about that crystal lattice and unit cell. Crystal lattice and unit cell. Crystalline solid is characterized by definite orientation of atoms, ions, or molecule. These atoms or molecules join to one another in the form of three-dimensional pattern. Three-dimensional pattern, maybe in x-axis, maybe in y-axis, or maybe in z-axis. Here we are going to learn about two important definitions. That is about the crystal lattice and unit cell. What are crystal lattice and what is unit cell? The regular arrangement of these species throughout the crystal is called crystal lattice. The regular arrangement of these species throughout the crystal is called as crystal lattice. A basic repeating structural unit of crystalline solid. A basic repeating structural unit of crystalline solid is called unit cell. So we have to learn about two definitions. What is about the unit cell and what is about the crystal lattice? The regular arrangement of the species, one of an arrangement throughout the crystals are called crystal lattice. A unit cell is the repeating units. Here, the unit of the crystalline solid, one of the unit of a crystalline solid, that's a repeating portion that we are saying unit cell. A crystal may be considered to a large number of unit cell. We can be joined, one by one joining like that, a large number of unit cell. Each one of the unit cell, they have a direct connection with a neighboring unit cell. They are connecting, such a way like that they are connecting. A number of nearest neighbors that surrounding a particle in a crystal is called the coordination number of the particle. The number of nearest neighbors that surrounding a particles in a crystal is called coordination number of the particles. Listen to me all. Here we can be draw one of the unit cell. Unit cell. I am drawing one unit cell. This is one of an unit cell. Here I am taking A. This is I am taking B. This is I am taking C. Imagine this is one of the unit cell. A, B is C. Here, first I am taking this area. Here the B here, the angle, this is about the 90 degree, am I right? 90 degree. This angle is about alpha. This angle is about beta. This angle is about gamma. Okay. That is 3 plus 3 parameters. One is about that crystallograph, that is a 3 parameters means one is about that length, 3 length A, B, C, 3 length A, B, C. Next one is about that angle. Angle means alpha, beta, gamma. This is one of the units. The unit cell is characterized by 3 edged length. Otherwise we can be say lactic constant, that is A, B, C. Here the angle between the edges alpha, beta and gamma. Alpha, beta and gamma. Next, what are primitive and what are non-primitive unit cell? Here, there are 2 types of unit cell. One is primitive and other one is a non-primitive. Primitive means the atoms are present in the corner. An atom is present at the corner only. Okay, this atom, sum of an atom, for example, this is, I am drawing, this is one of them. It says here an atom must be present at the corner. The corner present means we can be say This is a primitive unit cell. A unit cell that containing only one type of lactic point. The unit cell that containing only one type of lactic points is called a primitive unit cell. The unit cell that contains only one type of lactic point is called a primitive unit cell. Here, what about the non-primitive unit cell means? There are additional lactic points either on the face of the unit cell or within the unit cell. Here, suppose the unit cell is present on the center or in anywhere, that we are saying non-primitive unit cell. Next, we can be discuss one of the very important question. What are the primitive crystal system? There are 7 primitive crystal system. We have to learn this one. We have to draw this one of the 3-mark question. 7 primitive unit cell. As per the textbook, they have added like that cubic, rhombohedral, hexagonal, tetragonal, orthorhombic, monoclinic, triclinic. Cubic, rhombohedral, hexagonal, tetragonal, orthorhombic, monoclinic, and triclinic. But for the easiest way for understanding, I am changing the name, like I am change the order like that for easily understanding only. As your wish, you can be learn. For the better way of learning, easily understanding, I am changing the order like that. Cubic, number 1, cubic. Number 2, tetragonal. Number 3, orthorhombic. Number 4, rhombohedral. Number 5, hexagonal. Number 6, monoclinic. Number 7, triclinic. Okay, for writing the edge length and angle, we must thorough the edge length. What are the edge length and what are the angle? For the one-word question, so I am changing like that for easiest way for writing the edge length and also the angle. Okay, so try to learn this way like that. First one about that, what? Cubic, tetragonal, orthorhombic, rhombohedral, hexagonal, and triclinic. Listen children, that we have to look the diagram. First one, cubic. First you have to learn about the cubic. Here the edge length have some parameters. One is about that length parameter and another one is about that angle parameters. One is about the length parameter. Length parameter means edges, that means A, B, C. Am I right? Length parameter. Angle parameters, that is about that alpha, beta, gamma. Am I right? Don't forget that. 6 parameters. First, to try to understand the concept about the cubic. Here A is A value, A length is equal to B length and equal to C length. Okay, A length is equal to B length and Z is equal to C length. Here the angle is also, this is an first we can be drawn about the cube. I'm drawing one cube. This is not a correct, so you have to draw correct form. Okay, this is one of the cube. Here this is a A, here this is B, this is C. So A is equal to, the distance A is equal to B, the B is equal to C. Here this angle is about 90 degree, this angle is about 90 degree, this angle is about 90 degree. Okay. So we can say A is equal to B, B is equal to C. Alpha is equal to beta, beta is equal to gamma, that is equal to 90 degree. Next, as per my order, next you have to draw tetragonal. Here, please look at tetragonal. I am drawing the diagram. Here A is equal to B, but B is not equal to C. B is not equal to C because the C length is high. Am I right? As we are comparing A and B. So B length is, C length is high. So A is equal to B, B is not equal to C. Here alpha is equal to beta, beta is equal to gamma, that is equal to 90 degree. That is equal to 90 degree. Alpha is equal to beta, beta is equal to gamma, gamma is equal to 90 degree. That is about that. Tetragonal. Next one, orthorhombic. Orthorhombic. That orthorhombic, it is just like a cuboid. Am I right? Cuboid. Here, when I am drawing this one, like a cuboid. Okay. This is the point. Here A is not equal to B, B is not equal to C. Can you understand? A is not equal to B, B is not equal to C. In the angle, alpha is equal to beta, beta is equal to gamma, that is equal to 90 degree. Here telling about that different length means A different length, B different length and C are different length. But the angles are same. Approximately the angles are same. Alpha is equal to 90 degree, beta is equal to 90 degree, gamma is equal to 90 degree. What about the tetragonal? Here A and B are same length, but C is not same length. We can be said the different length. Here angles are same. Angles are 90 degree. What about the cubic? Length are same, angle are same. Am I right? Length are equal and angles are equal, are same. Next, rhombohedral. I am drawing the rhombohedral. This is about the rhombohedral. Here what is about the length? Same length. Almost all same length. Same length means A is equal to B, B is equal to C. Alpha is equal to beta, beta is equal to gamma. But gamma is not equal to 90 degree. Gamma is not equal to 90 degree. Can you understand? Alpha is equal to beta, beta is equal to gamma, gamma is not equal to 90 degree. That is about the rhombohedral. Same length, almost the same length, but angles not equal to 90 degree because A is equal to, alpha is equal to beta, beta is equal to gamma, but it is not equal to 90 degree. Next about hexagonal. Fifth one is about the hexagonal. I am drawing the diagram for hexagonal. First start like that. Here, A, what about A? A is equal to B. B is not equal to C. The length A is equal to B. This is equal to this, almost equal. But C have some distance, am I right? C is not equal. B is not equal to C. So we can write the angle. Alpha is equal to beta. That is equal to 90 degree. But gamma is equal to 120 degree. But gamma is 120 degree. Okay, A and B are the same length, but C is not same length. Alpha, beta are same angle, that is 90 degree. But gamma is equal to 120 degree. That's about the hexagonal. Next about that, monoclinic. How can you draw the structure of monoclinic? Monoclinic also different length. For A is not equal to B, B is not equal to C. But we can be draw. In our figure, almost they mention like that the same length, but it is not the same length. Monoclinic is not the same length. A is not equal to B, B is not equal to C. First I am drawing. A is not equal to B, B is not equal to C. Alpha is equal to gamma is equal to 90 degree. Here beta is not equal to 90 degree. Beta is not equal to 90 degree. Alpha is equal to alpha is equal to gamma is equal to 90 degree. Beta is not equal to 90 degree. That is about the monoclinic. The last one about the triclinic. Here A is not equal to B, B is not equal to C. A is not equal to B, B is not equal to C. That is a different length. Different length, and also we have different angles. Different length, and also we have different angles. A is not equal to B, B is not equal to C. A is not equal to B, B is not equal to C. There is a different length, different angles. Alpha is not equal to beta, beta is not equal to gamma, gamma is not equal to 90 degree. Gamma is not equal to 90 degree. Let us, I am creating a small tabular column like that, a small tabular column for easily understanding. Okay, only for easily understanding. Okay, just then only after learning this tabular column, try to memorize it, this tabular column, then we can be draw the diagram easily. Okay, try to memorize it, then we can be draw easily this diagram. First tabular column, make it 3 column like that, 3 column. First is about the cubic. Second one, tetragonal. Third one, orthorhombic. Fourth one, rhombohedral. Fifth one, hexagonal. Sixth one, monoclinic. Seventh one, triclinic. Once again, first one cubic, tetragonal, orthorhombic, rhombohedral, hexagonal, monoclinic, triclinic. Listen all of you, this is the first 3, you have to write like that, first 3. A is equal to B, B is equal to C. That is the first one, cubic. A is equal to B, B is equal to C. Second one, A is equal to B, B is not equal to C. B is not equal to C. Clear? Third one, A is not equal to B, B is not equal to C. A is not equal to B, B is not equal to C. First one, A is equal to B, B is equal to C. Second one, A is equal to B, B is not equal to C. Third one, A is not equal to B, B is not equal to C. Again repeat the three same, 4, 5 and 6. Again you have to repeat. Okay, yeah. That is first one you have to write fourth one like that. Second one, fifth one. Then third one, sixth one like that. You have to write. That is first one. What is first one? A is equal to B, B is equal to C. Again you have to write. What is the second one? A is equal to B, B is not equal to C. Next, what is the third one? A is not equal to B, B is not equal to C. Then the seventh one, just we are writing the opposite. Just we are writing this, the sixth one. Sixth also same, you have to write seventh. A is not equal to B, B is not equal to C. A is not equal to B, B is not equal to C. Okay. Next, we have to write the angle. For the angle, first, second, third, you have to write same. First, second and third, you have to write same. Alpha is equal to beta. Beta is equal to gamma. Gamma is equal to 90 degree. Second one also like that. Alpha is equal to beta. Beta is equal to gamma. Gamma is equal to 90 degree. Third one. Alpha is equal to beta. Beta is equal to gamma. Gamma is equal to 90 degree. First three. After writing the first three, you go to the last one, seventh one. Just you have to write just on opposite. Just opposite. Alpha is not equal to beta. Beta is not equal to gamma. Gamma is not equal to 90 degree. Just we are writing the opposite. Okay. Alpha is not equal to beta. Beta is not equal to gamma. Gamma is not equal to 90 degree. After 7, 4 over. Then we have to write the remaining 2. We have to write the remaining 2. Come to the fourth one. What is about the third one? Alpha is equal to beta. Beta is equal to gamma. Gamma is equal to 90 degree. Am I right? Here, alpha is equal to beta. Fourth one. Alpha is equal to beta. Beta is equal to gamma. It is not equal to 90 degree. It is not equal to 90 degree. So out of 7, 5 over, remaining 2. Remaining 2 means a small change here. That is a fifth and sixth, a small change. Alpha is equal to beta, that is equal to 90 degree. Okay, alpha is equal to beta, that is equal to 90 degree. Then gamma is equal to 120 degree. Gamma is equal to 120 degree. Next, monoclinic. Alpha is equal to gamma is equal to 90 degree. Beta is not equal to 90 degree. Beta is not equal to 90 degree. Next, the Brevis lattice, please, page number 182. Cubic having 3 structure. Please try to draw this structure. Cubic, tetragonal, hexagonal, orthorhombic, monoclinic, trigonal, tricyclic. This is a Brevis lattice about the 14 diagram having. First is about the primitive, body-centered, face-centered. About the cubic, tetragonal also 2 diagram. Primitive, body-centered. Hexagonal, orthorhombic, 4 having. Primitive, body-centered, face-centered, and a basic face-centered. Monoclinic having 2, primitive, basic, face-centered. Trigonal 1, triclinic 1. These are the diagram. Try to draw this one. Again, I will explain what is about the body-centered, what is about the simple cubic, what is about the face-centered. I will explain the next class. Try to learn this diagram. If you have any problem, please ask me. Okay. About today assignment. Today assignment is the 7 primitive crystal system. 7 primitive crystal system. Okay, please try it. Thank you all of you. Thank you. Have a nice day.